Okay, I'm gonna quickly go through some example problems that I've created based off of the practice test and the test from chapter 11. So we've had some problems with multiplying / dividing fractions and then simplifying them, so that's what I'm primarily focusing on here. We will just start with number 1. So remember, you have to take the second fraction, and we're gonna take its reciprocal, and we're gonna multiply these two together. So I'm gonna get x squared over y squared times 3y over x. So see how I took this and I just took its reciprocal, and we're multiplying instead of dividing now. And this is going to equal, I'm multiplying, so when I multiply fractions, I'm looking at the numerator, I'm just multiplying the numerators together, and then I'm looking at the denominators, and I'm just multiplying the denominators together. So this is going to be x squared times 3y. So I'm going to write it 3y x squared. Down here, it's just y squared times x, so I'm going to write y squared x like this. And now for simplifying it, I'm going to look at the numerator and the denominator. I'm going to find common factors. So common factors are just numbers or variables that are multiplied to other numbers. So we're going to find common multiples. So you can see here that we have a 3y, x, and an x all multiplied together, right? And down here you have a y and an x all multiplied together. So I'll actually rewrite. Let's do this. 3y, x, x all multiplied, y, and x all multiplied. So since I have multiplication here, and a division sign here, I'm basically getting x over x, right? Which is just 1. So I'm going to get rid of this one. And then same thing with the y's, right? So I have a y here and a y multiplied here with the division sign is just looking like 1. So I end up with just 3x over y, just like that. Alright, let's do the same thing down here. It's going to look a little bit different, but we're going to use the same idea. So I'm taking x plus 16 over 2 times, so this looks like 2x over 1, so the reciprocal is going to be 1 over 2x. Multiply the top together, multiply the bottoms together. Okay, so this is as broken down as it can be. You see that we have an x here and an x here, right? And up here we had an x and an x, and we were able to cross it out. We are not able to cross this out because there is this plus sign here. So the difference between this and this is that there was a multiplication sign here, which made it possible to exit these out. But this has a plus sign, which means the full numerator does not have a factor of x. So this is actually as simple as we can get it. Yeah. Okay, we're going to move on to the next one. X squared plus 2x minus 3 over x squared times the reciprocal of this, which is x over x minus 1. I'm going to multiply this all together. So I'm multiplying the x to this polynomial here, which means I'm distributing to each term. So I'm going to end up with x cubed plus 2x squared minus 3x over, and then the same thing here, this x squared is going to each term here. So I'm getting x cubed minus x squared. So really quickly, I can see that each of these terms has an x, right? This has 3 x's, this has 2 x's, this has 1 x. This has 3 x's, this has 2 x's. So I'm going to take the least amount of x's, and that's how many I'm going to cancel out or take out. So I'm going to end up with x squared plus 2x minus 3 over x squared minus x. So all I did here is I took this x out, I took one of the x's out here, and I took one of the x's out here, and I canceled it by taking one of the x's out here and one of the x's out here. So since this x is multiplied to every term, or this whole polynomial, it is a common factor for all of these, right? Because I was able to take it out and multiply it to this whole thing. So I can cancel that x out, which is why I'm left with this as an answer. All right, we're running out of a little bit of room. Sorry, bumped it. So this one's gonna be tight. Actually, I can just talk about this. So some common mistakes is we wanted to cancel out the 5s to cancel out the 1s. We're not allowed to do that because 5 isn't a factor of this whole thing. It has to be a factor of this whole thing and this whole thing in order to be canceled. So this is actually as simple as it can be, right? We're not able to just cross these out and cross these out. It has to be, 5 has to be pulled out from this whole thing. Well, never mind. So this is as simple as it can be. This one is a little tricky because it looks like these are two completely different polynomials. But I'm going to rewrite this so that we see that they are actually very similar. So all this is -1 times 3 minus x over 3 minus x. And since 3 minus x is a multiple of 1, and 3 minus x is, of -1, 3 minus x is a multiple of the denominator, I can actually get rid of the 3 minus x's, and I'm left with -1. So the reason this works is if I distribute -1 here and -1 here, I get -3 plus x. Now this one is probably the one we've had the most trouble with. And it's kind of complicated, but we're asked to rewrite this basically as 2 different fractions. Really, we can write it as 3 fractions. So the way we add fractions is we need a common denominator. And so the way we can break apart fractions that have polynomials in them is I can just write these as addition of fractions, right? I can add everything in this top together because I have common denominators with all of these. So I can break this fraction down into something like this, right? And so the way I would do write this as a mixed number is I'm going to look for a combination of 2 of these 3 monomials that matches this one here. So initially I'm going to look at, we'll do this over here, 2x squared plus 3x. Now is that like, is that equal to something, that's going to be confusing. We'll use a. Something times x plus 3. So I see that there's an x squared here and an x here, so maybe I could do 2x times x plus 3. So when I distribute this here, I get 2x squared, which matches here. But when I distribute here, I get 6x, which doesn't match here. So 2x cannot be a. Let's see if there is a different number. So this cannot be a multiple of x plus 3. So let's try this. Let's try 3x plus 9 equals something times x plus 3. So I see an x here and a 3x here, so maybe I can do 3 times x plus 3. So when I distribute here, I get 3x. When I distribute here, I get 9, which is a match. So I have a match here and a match here. So I'm going to separate this fraction out to be 2x squared over x plus 3 plus 3x plus 9 over x plus 3. And I can pull a 3 out of this top one. We're running out of space, so let's do this. Sorry, the video that I just posted cut out what I was doing at the very end because I had my paper too high. So I'm gonna just explain what I did there in the last part. So we got to this step here, right? So separating it out properly, trying to figure out how to separate it out. And so we found a match, which is what we did here. Found a match with x plus 3, and so we separated it out like that. So the next step is taking that, so I'm just going to write that down here, plus 3x plus 9. And I'm going to extract out the common factor here. So the common factor is going to be x plus 3, and I get there by taking out a 3 from the numerator. So that's going to be 3x plus 3 over x plus 3. So now I have a common factor for both the numerator and the denominator. And since it's multiplication and a fraction is division, these cancel each other out because of inverse operations. And now I'm left with 2x squared over x plus 3 plus the integer 3. So that's how we write this fraction here as a mixed number, or an integer and a fraction. The way we want to do it is we want to find a match with the denominator, so that we can extract out the common factor, cancel that out, and then we're left with an integer. So that's how you do that. Let me know if you have any questions on this. If you want to see more of these, I can definitely do that, but you have to let me know.